For assignment 7, we're going to be doing P9-14, the crank assembly. This is got some interesting geometry in, so this will kind of transition over from design, drafting, to mechanical design into the engineering. So when we look at that spectrum, looking at a project like this, it also plays into the manufacturing, and the first question is how many? Materials, not so concerned about materials. There's things that we could adjust to analyze cost, but the how many is going to drive some of at least some of the decisions that we're going to make in the manufacturing process and the materials. So if we're making one, okay, we are not concerned about making fixtures and finding faster, better ways to do the manufacturing. We're making 100, okay, it becomes a little bit more. 1,000, yeah, we're going to start optimizing. Tens of thousands, we're going to really put this under the microscope and see where we can make good decisions. So let's go look at the bill of materials. This does have a bearing, and typically bearings. We'll go look at the analysis. Let's see, deep groove ball bearing BS292. I don't really recognize that one, but we'll take a look at the bore, and depending on what standard they're pulling from, and the types of geometry that we would be concerned with, we'll go out to some place like McMaster or Granger or one of the vendors and determine what we're going to be able to buy. And again, cost is driven by quantity in some cases. So if we go to a bearing supply and we're going to order 1,000 of these, we want to know what their specification is. So let's get started with the support. And we'll go down through the list here and find that. The one I haven't done before is the SAE spline. So I've seen them. I know what they as a drive component. I know what they do, but I haven't created one in a model, so I have to look up some geometry there. All right, so on our support, billets rounds, we have symmetry, relief on the bottom side, clearance holes. Nothing real fancy here. The one thing of note is a lot of the ABEC bearings, ABEC is standard I'm most used to, have a slightly raised area for the inner race. So um, when we're looking at that bearing, the other thing is a ball bearing has quite a bit more load, but since this is a hand crank, really got to question the justifying this roller bearing. Usually those are RPMs somewhere in the thousands of RPMs, not, wow, look at me, I'm cranking this at 10 RPM or 100 RPM if I'm um, really spinning it. The other side is the loading component. That whatever this is going into, and we are engaging with the hand crank, the the forces that are being applied, depending on which direction, push, pull, um, is it vertical, horizontal, is the clearance on this hole to the shaft going to be sufficient? So when we get over to the assembly, we'll revisit some of those questions, and some of those questions hopefully will be answered along the way. All right, so we'll fly this out of the way. This is an inch, so file new, part inch. At the 1.0s and the 4.0s, if this was in metric, this would be a really small hand crank. All right, so front plane, anytime I'm doing symmetry, we go right into the center line. I'm symmetric about the vertical axis. We'll make it infinite length. Advantage of infinite length is that I will not run out of center line. I'm going to go with let's make just the simple geometry. I'll worry about the fillets later. We'll put some dimensions on this. So the 1 inch, the 4 inches. So this is a pretty good chunk of material already. If this isn't steel, we're going to be at the weight issue. And on the weight issue, that comes back to shipping and the overall what it's being what the application. All right, so with my center line and symmetry, far side of the center line is the full or the diametral dimension. In between the center line and the object is the half or the radial dimension. Since we're not revolving this, I tend to think of it as a full dimension. So 8 inches, and because I have the little D next to the cursor, I will be right back into picking for the geometry. Now on the print it was 1.5 by 1.5, so my choice is, well, I can do the math, or we can just hit escape and go pick the center line, stay in between, and we'll be at the 1.5. All right, the 2.5 would be an over-defining. Now it stayed with the center line, so escape one time. And if I go to the 2.5, it's going to make this dimension driven. All right, a driven dimension is just going to show me for reference. And notice its extension lines are in a lighter gray than the black extension lines. All right, so it's useful information, but we have to decide, if we want it there for reference. For the undercut, I'm just going to go back to the centers, and let's see, this was 2 inches from there to there. All right, I can't pick the bottom because I left that hole. If I'm going to trim this out, I don't really need to worry about it being a trim. And looks like we're missing a dimension. So if I just kind of go through there, it looks like about a 1/2 inch of relief. We may find out that we get to the assembly that number changes. So since it is a missing dimension, I'm going to recommend that we go to an inspection, that when we pick on the odd brown, that denotes it as an inspection dimension, and I might even mark that for drawing. Now I'm not in the habit of inserting for the drawing, or inserting the dimensions for the drawing, but if I happen to put one of these on there, usually I will remember it. All right, so I'm going to pull this back up and over since that popped off my screen. Right click, mark for drawing is checked, and it will look different than the other dimensions. So at the very least, it's a call out that says, hey, we need to check this out. All right, so from left to right, everything inside. From right to left, everything crossing. So I do want to include the center line. If I wanted to see the preview, then I would go left to right. But since we're going to pretty much end up with everything anyway, we'll go ahead with the geometry. Now the choice is, do I include the through hole in this sketch? And I'm inclined not to. So we have extrude. We're going to pick our region. Center line denotes a region. I'm going to go midplane just for to try that out. I'll go ahead and hit OK. We'll go into our sketch on the front plane. We have a 3/4 inch through hole. Now I could do this as the hole wizard if I thought that there was going to be a tolerance or an advantage, something that we might want to take with the hole wizard. All right, so selecting the origin, control selecting the center point. We're going to make those vertical. Its center point is 2.5, so either from the origin or the base. And if you go to the center, just remember that you don't get the min, the max, in the center. And usually the circle is a bigger target to select. So I'm going to go that route. We have 0.75, 2 decimal places, and we're going to cut extrude through. Now, if I wanted to do the contour and region thing here, I could go ahead and share this sketch. All right, rather than doing a completely new sketch, we'll go this way. Now, they call this out as a counterbore. All right, so let's take a look at the designation counterbore of 2 inches by 0.69 deep. That being a bearing housing, and granted, again, it's a hand crank. When we look at this from our mechanical choices, I'm tending towards a sleeve bearing or a couple of sleeve bearings that are maybe $1 or $2 a piece, as opposed to a bearing that's 15, 16, $20 a piece. All right, so this counterbore definitely needs a tighter tolerance, and that's where we get into the design, and making these decisions goes more towards the engineering. So to start with, we're going to go with the 2-inch, and then when we go to the cut extrude, we're going to activate the contours and regions. And if I pick the circle, then I get the contour. If I pick inside of the circle, then I get the region. And they both, in this case, do the same thing. It's a matter of which one's going to be easier to pick. So we get the through all. I want to share that sketch, so making sure that that sketch is highlighted again. We're going to go into the extrude cut, switch to blind, and this becomes the 0.69. Now, on the do you recognize your fraction size, I know from experience, just that I've used these an awful lot, that 0.69 equates to 0.6875, which is 11/16. All right, so 5/8, 11/16, 3/4, and that gives me the depth. So there is an advantage to being able to recognize those fractional elements. All right, so sketch 4. Now, since the mounting holes, those are called out somewhere. No, I guess they're not. Again, we'll go with the 1/2 inch and inspection dimension, but since I don't really know what those are, this is also a good place to use the hole wizard, because I may decide that I want those to be the threaded element as opposed to a through hole. We can start with the through hole and we can get our positions in. For this one, I'll just do a center line from midpoint to midpoint. Doesn't necessarily need to be infinite length. Select the point, select the center line, mirror the entities. All right, and then they're showing this as 1 inch from the end. Positionally, I always feel a little bit better about going between the two. So we'll put that in. And since I would want to know the separation to whatever I'm mounting this to, a driven dimension that does the math for me would be nice. So origin and one of the center points. So picking the origin, holding down the control button, picking our center point, we go horizontal, and we go ahead and accept. Now here's where the advantage comes in. I decide, well, oh, I guess I was in metric. We glance over here and go, 10 millimeter, wait a minute, what happened there? All right, so I did not look through the rest of this. Anti-inch, we're going to go to fractional drill sizes. If I were to go to clearance, which this one probably would actually be a clearance hole, so if we go to screw clearances for a 1/2 inch, should make it about 510, 513, somewhere in there. Find our 1/2 inch, normal if we want to see the custom sizing. So that went to 530. I don't know that it needs to be that big. So we close it. All right, so it went to 515. and up to next is fine. We already did the positions, so we'll go ahead and accept that. All right, so the last thing is the fillets, and let's see, the fillets in rounds, 1/4 inch, 250, looks like everything but the bottom 4. So we'll put in the first fillet, go to the next fillet. We'll go ahead and make sure that that is selected. And when I reselect those edges or deselect those edges, we'll take those out of the mix and make sure that our dimension is 0.25. And we'll go ahead and accept. All right, so I have not created a project folder. So we'll see where this falls out. I need to get back to my projects. All right, new folder. And this is going to be my assignment 7 folder. And this will be the support. Now the naming and the other items that come into play here will go with whichever one you prefer. I'm going to stay with, hopefully I'm going to stay with the support. They're calling it steel. So basically low carbon, mild steel, pretty much all the way through. And when we get to the part numbers, we'll do that out of the drawing. We can go do those as we go, which is probably preferred, but we'll deal with those when we get to them. All right, so we'll stop this video and pick up the next with the rest of the parts.